Hi there. Good morning, good afternoon, and good evening, depending on where you are in the world. Thank you for attending this webinar, Securing the Automated Pipeline, a tale of navigating the microservices culture. This is jointly brought to you by Contrast Security, the leader in application security testing, and Beeline, the preeminent global contingency workforce solutions provider. Now, before we dive into the presentation, I'd like to go over a few housekeeping items. If you have a question at any time during the webinar, please use the Ask a Question tab located below the player. Your question will be addressed during the Q&A session at the end. At the end of the webinar, please also take a moment to rate this presentation and provide feedback using the Rate This tab below the player. Also, if you have any technical difficulties, go to the bottom of the page and click on Support for Viewers. And finally, a recorded version of this presentation will be available at the same URL shortly following its conclusion, so feel free to share it with your friends and colleagues. So we thought it would be really beneficial to the audience today to highlight this webinar and provide a unique customer point of view, basically one that traces the steps on how Beeline started their journey in bringing the right stakeholders on board, how they developed a winning strategy and executed toward that, and deploying secure software with security, development, and operations and engineering all bought in. So now I'd like to introduce the speakers for today's presentation. First, we have Julie Chiquillo. She is the VP of Information Security. We've also got Brandon Grady, SVP Software Engineering, and Ben Fink, Threat and Vulnerability Program Manager. So over to you folks at Beeline. Take it away.
Hi, thank you. My name is Brandon Grady. Thanks for the introduction. I wanted to first point out and just highlight a couple of the things that might be relevant about Beeline to this presentation. Beeline is a SaaS software provider in the HR space. A lot of our data is employment type data. So we do have quite a bit of private type data, PII, and things that we have to be concerned about when it comes to vulnerabilities and threats. So just as a little bit of background on Beeline, we do target Fortune 500 companies. We are a contingent staff software solution that kind of fits in the niche outside of where your typical ERP type systems fit. And we do house quite a bit of employee data. So we want to take you through a little journey today, a software journey and how software is built, and then how we protect that software. If you see this picture on the screen right now, this was done by Ben, who's a much younger man than I am. Back in Ben's day, this is kind of how things started with a web application. Back in my day, the web hadn't yet been invented, but you can imagine, go back into the early 2000s, late 90s. Where basically you had an idea, you rented some space in a colo somewhere, bought a server or two, installed an operating system, and away you go. And most importantly, the speed at which that software was released, most likely right after the initial install of it, was very, very glacial. Once a quarter was probably pretty fast for most shops back then. So it was a highly waterfall type approach to software development back then. If you go to the 0.5 number on this crawl here, would probably be about 6 to 8 months of planning, after which we do 6 to 8 months of coding, throw that code into UAT, do some scanning, enter tickets for vulnerabilities, fix those tickets, redeploy, retest, redeploy. And then we do our functional testing and fix those bugs and redeploy and fix more bugs and redeploy even then. And then at the end, we can finally do some pen testing and start thinking about security. The point here is software back then was moving at what we thought was a good clip, but what today we don't necessarily think that might be the case. So yeah, the coup de grace, and I miss it. Once we did that 6 months worth of testing and planning and fixing and testing and scanning, as always happened, it was almost infallible that we would spend a weekend, if not longer, continually battling the deployment failures and the different pieces that we forgot during the time. Everything was manual back then. We pushed the code manually. We tested the code manually. So finally, after a long, long time, we're able to get that code into production and get it to our clients.
Thanks, Brandon. This is Bannon. So my job is on the security team was I would make sure that we had a lot of comfort with the security of the solutions going forward. So we had a number of tools in our tool set that could sort of fit those timelines, right? We could run static source code analysis on software. We could do dynamic scan analysis, and we'll be very generous and say we could get those done in 8 hours or 2 hours, right, for the dynamic scans. We could do vulnerability scans on the web servers, right, or the database servers, the different components that were outside of the software development stack. We could do config management on those devices with, like, an agent that we could deploy, or some type of a scanner that would live on the network that could go ask each one of those things one at a time. How are you configured, right? We could do attack detection with network devices, right? Inline intrusion protection systems. We could deploy agents to it. It was really easy to do, and we could also, by the way, in those final weeks of getting ready to move to prod, spend some time maybe even tuning a web app firewall. We had plenty of time to do all that stuff. Life was good.
Thanks, Ben. And so about 2 years ago, the development team decided that this was probably not the way that they wanted to continue going forward. One of our architects happened to read this book, The Phoenix Project, and started our journey in the DevOps world. At the time when the developers came to me and they had started the first container environment, they literally broke every one of my security tools. And so it's known as the time when security said, "You built what?"
So yeah, to give a little color on that, I mean, we didn't do it just to mess up Julie's security tools. That was part of the motivation, but the larger impetus was to take our time back. We wanted to move to an environment where we could continuously deploy code, much closer to the time when the code was developed. Imagine a time when it was the 6 months between code and deployment cycles, or even 3. You might be developing something on January 2nd, and it doesn't get deployed until June 30th. That's an awful lot of time of context switching, and gives you an awful lot of time to forget what your thought process was back when that code was delivered, making things just go longer and longer. So what we wanted to do was we wanted to make things that could go quickly all the time with zero downtime as much as possible, and deploy it as close to that development cycle as possible. In fact, make the developer who was in charge of the code change responsible for supporting it all the way through to production, versus passing it off to a QA team who then passes off to an operations team who then crosses their fingers, deploys it to production, and hopes for the best. So we, taking direction from the Phoenix project, we came up with a project where we decided we would try to deploy as many as 20 times a day with zero downtime. And we thought that wasn't actually possible, but I'll give away the secret now. We're now deploying as many as 30 to 40 times a day with this environment, with these pieces in place, which has really moved us very quickly into what the next slide will show you, a paradigm shift. It's not just a shift in how we deploy, it's been a shift in how we think about delivering software. Now, since you can't control the order of things, well, containerizing our application, which started out as a very monumental or monolithic application, required that we split it into a bunch of different pieces. And each of those pieces needed to be independent of one another. And not only that, you had to be able to deploy them independently of one another, potentially out of order. So that really switched the way we had to think about how we delivered software. First of all, we had to make sure everything was very well tested in an automated fashion at all points. So we spent a lot of time building out our build pipeline, under which quality could be measured and automated, And not only that, the deployments themselves could be automatically done. We didn't want an ops team who had to sit around and wake up at various times during the day just to deploy the software. So the software had to be deployed in an automatic fashion with our tools in-house. So we're talking about a software change that might get conceived in the morning, and by 2 o'clock in the afternoon, it could be in production. That's the kind of speed that we were envisioning, and today we are actually experiencing that kind of speed. The way it happens is through our build pipeline. The build pipeline mandates that all code is done in development. It's coded and tested, automatically tested. We then merge that code into a master branch, and that is a key for our automation to then deploy it to all development environments and integrated environments. Once it gets to those environments, it executes tests, it executes static analysis through SonarQube, and it executes unit tests. Once all of those pass, that can then be moved into our QA environments, where it is then the QA engineer's responsibility to test it in an integrated QA environment. And once they're done, and once they're satisfied that all those tests have passed and their functional testing is complete, they push the button and that goes to prod. And we've got several actual prod-like environments that it goes to all at once. And it is all done automatically through our build pipeline process.
So as you can tell from what Brandon just laid out, this was a not only a huge shift in the way that the developers were thinking about deploying code, really changed the way that security had to secure the code. This was a huge shift from we no longer had time to scan. We couldn't do static and dynamic scanning. We could no longer take 2 weeks to pen test. We could no longer pretty much take a good month or even quarter to test all the code that they might be putting out into production. So this change in mindset is something that's really important for any security team that's looking to help a development team go to DevOps. You do have to understand that the old ways of doing security need to change. And go ahead and go to the next slide, Ben. So what that means is you no longer have 8 hours to do your static source code analysis. You don't have 2 hours for dynamic scan analysis or another hour for vulnerability scanning. It really changed the configuration management, attack detection, and then the 1 to 2 weeks for tuning a firewall. So go ahead and go to the next slide. Oh, thanks, Ben. So what did this mean for us when we started the project? Well, the first thing it meant for me was I had to build trust with the developers that I would not slow down the pipeline. So the first thing we did was we sat down and I had the developers whiteboard the pipeline, what they had envisioned, and we talked a lot about what they would need security to do in the pipeline. This really changed the way that the security team interacted with development, whereas before we showed up and said, here's your test results and you need to fix all of these things. I now was asking the development team to envision how security could work in the automated pipeline and what sort of timelines they wanted to see from the security tools. So, yes, thanks, Ben. And the big thing that we did was we gave the developers the power to say no to any security tools. So when I initially started this project and they broke all of my security tools that I had 2 years ago, I told them I wouldn't stick anything in the pipeline that they didn't first vet. Now this was really big in building trust, like we mentioned a few slides ago. What it meant was that it was going to take me a little bit longer to go ahead and get a vendor online. What I would do is cold call vendors. We would then, once they passed my initial assessment, I would have the pipeline architect interview the vendor. If they could get past my pipeline architect, they then got to go through one more call with Brandon and the application architect. So there were quite a few vendors that made it through me, couldn't pass the architect, or might have made it through me and the architect, and would get to Brandon and the application architect, and we would have to cut them loose. But this took about 6 months, and once we finally did find the right vendor, it really helped make sure that security would not slow down the pipeline, and it also helped build bridges between security and the development team. So yes, even after you deploy, you do have to continue talking with the development teams. It's crucial that you spend a lot of time listening to what they need. You can no longer tell them what you need to happen. You really have to take time, understand what it is that they need in the automated pipeline. And so you do have to continue talking with the developers. One thing that we do often recommend to people who are new to the process is that you make sure that you have liaisons back to the development team, and that's really important to ensure open communication. And I think, Ben, I'll go ahead. You can go to the next slide.
Great. So if we catch up now and think about what our new security requirements are that we have, we've got a few things here we're going to talk about, right? We have to be able to match the deployment speed that Brandon mentioned earlier. We have to be able to work in the multiple different environments where our applications may exist. We've got to be able to provide some certainty to the product management team that the production code that we send out is clean. We've got to keep the developers happy, really important, as Julie was just elaborating on. We also have to keep auditors happy. As Brandon mentioned earlier, we have a lot of Fortune 500 clients, and boy, do they like to do audits. And then as a self-assigned goal, we decided we would keep ourselves happy as well. So let's dive into matching the deployment speed. So if you remember this slide earlier, we talked about optimistically getting a static source code analysis back in 8 hours and a dynamic scan in 2. We don't have anywhere near that amount of time, right? We've got roughly 15 minutes as sort of a maximum outside window that we can work here. So we know that the standard software tools like static and dynamic scans are too slow. So we started taking a look at something called interactive testing, right? This is interactive application security testing, or IaaS, as you'll see it sometimes abbreviated. It's kind of cool in that you can sort of piggyback the same functional testing that you're already doing as part of your QA process, which, let's be frank, that's what security is, right? It's just a very specific kind of QA. We needed a tool that we could run both in sort of like the standard on-prem, like, VMs, as well as maybe some of the newer DevOps platforms that we were taking a look at. And we needed it to handle a wide range of things, not just the platform it could run on, but also the languages that it could understand and run really, really quickly. So we ended up deciding to use Contrast Security for that solution. And we'll talk about this in a few more minutes, but it was able to meet all of our needs here in terms of language coverage, application stack coverage, and speed. So the next thing we took a look at was the ability to work in multiple environments, including containers. So in the good old days, right, we had a list of servers that were like the production and like the UAT and the QA servers, and we knew we could run vulnerability scans to make sure that those things were getting patched like they were supposed to. We had various options for config management. All of these just went out the window, right? You can't install agents on the containers. They're too big and heavy, and that's not the way that those things are intended to work anyways. So what was really important for us is that we knew that we had to have tools that we could run wherever the code went, right? So what's great about the IaaS technology that Contrast uses is that it runs as basically a component of the app, right? It's deployed as part of that application. So whether we're putting it in containers in our own Kubernetes cluster, or we're deploying it to virtual servers in our co-location centers, or we're experimenting with some cloud service providers, everywhere we go, we're getting the same instrumentation on the application. And we were able to build this into the deployment process. So we know that the software, and we're going to talk more about this in a minute, this is really key, but we were able to deploy the Contrast agent as part of a standard deployment process, making sure that anywhere the code showed up, we knew it was running and we could keep an eye on it. One thing that I think is really important for security folks that they often kind of get a little overwhelmed by is the new nature of containers. And the containers, especially Docker containers, are not hard. In fact, they make a lot of things really easy for you. So here is a good example of just a standard sort of a template of a Docker file, right? This is basically the recipe that the container is built from, right? And so I encourage you, if you are supporting an environment where they're using Docker, this aspect will be one of the greatest friends you have, because if you look at what this is doing, this tells you everything about this container, how it's going to operate and what's on it in one easy-to-read file, right? And you can even script up checks to look at this for various things. So if we start at the top, you can see this particular one, it's starting with a base image of Ubuntu Linux. We can go next. We see they're going to install some software that are dependencies for the particular application that whatever this is going to run. We see them install Ruby along with all of the specific command line arguments they made to install Ruby. We can see that they've installed SQLite 3 in here, and we can see where they've also installed some other, set some local environment variables. So that tells you everything in one screenshot that you would spend hours trying to figure out with agents and network scanners and all kinds of things. So get comfortable with this, because this will really give you a lot of value. So we talked about making sure we could validate that the code was running well with Contrast, right? Contrast could report back to us and let us know those things. But we also wanted to make sure we could verify the integrity of the underlying container software. So some steps that we did that were really valuable was, number one, establish a trusted registry of images. When Brandon mentioned earlier that the whole pipeline was automated and built, that's really true. There are only a few folks who would even have the ability from a permission standpoint to be able to actually create containers in any of the production environments. And so by having it all be automated and by only allowing trusted images to get deployed, we can have vetted ahead of time the Docker files and the corresponding images that get brought up so that we know exactly the state of those things and what's installed and how they're configured. We only allow the deployments of accepted containers and software. We'll talk about that in a minute. But once the software is tagged in the software repository is approved for production, that is the requirement that the build process has before it'll put anything into any of our production environments. You can script up checks for changes in any of these registries, right? So first of all, you can make sure that only approved ones get pushed in there. But if any of a stage, let's say, the things that you're preparing to review, you can script up checks for those. Really easy, and you can even have it just do simple things like send you an email. This also, by the way, is a good place to tackle some of the supply chain concerns that have come up in security. There was an incident just a few months ago where an upstream package that's really popular in the Node.js world that a lot of people would install on their app through the NPM, the Node Package Manager software, was compromised. And so people, without knowing it, were installing into their app, right, malicious software. And this is a great place that you can get a comprehensive top-to-bottom list of the libraries that are in your software application as well as in the underlying servers or containers. So if you ever want to know what it is that is everything that's used, all the components that make up what is actually the sum total of a running application, this is the place where you can figure it out and figure out what steps you want to put into. For example, if you're going to allow NPM installs from the global NPM, or if you're going to set up your own package management. You can also do a lot of configuration checking here too. So if you have very specific requirements about how things are configured, this is your place to go to see how is that actually going to be configured, because you know it'll come from these trusted registries and from branches that are tagged. You have the ability to inspect the configuration before it gets deployed. Number 6, one of the things that was really impressive, I think for us early on in the experience of deploying Contrast was one of our customer audits asked the question of all of the libraries that made up the software application. And between the checking that we did here that we just talked about for the underlying container, as well as the library listing that Contrast gives you when it is looking at the application or when you're instrumented to use the Contrast solution and you're checking your application, we were able to respond in 5 minutes because we had an up-to-date active dynamic list that we knew was 100% correct, and the customer was blown away. They called us back and said, no, we need an up-to-date one. We said, yeah, that is the up-to-date one. Like, we just pulled it. That's fresh as of like right now, and they were amazed. So this is where you actually can put that into play. Okay, so the next thing we'll talk about is providing some certainty that the production code is clean. Remember, we talked about this at the beginning. We want to give the product manager some assertion that things that come out of development that we end up in production environments, we can verify to them have gone through security testing, and we've vetted them to the point where they meet our minimum standards to operate. So we did this in a couple of phases. The first one is what we'll call the Gatekeeper Approach. So you have a bunch of environments here, sort of mimics how Beeline works. And the idea is you want to pick one of these that is the demarc point between everything on the left of this is technically development, where we're letting things happen, and everything to the right of this is considered production, right? So for us, we sort of designate this sandbox environment as our gatekeeper location, right? So on the left of that, back in the dev cycle, we have sort of this nightmarish Mad Max hellscape where who knows what's happening, right? The developers are doing their thing and building new software. We installed the Gatekeeper, which is contrast, and a few other things for us right here on the sandbox level. And what that means is the only things that gets through into the UAT production and other production-like environments are the clean code, which of course is all rainbows and unicorns. This is a great way to implement it because you only have to really instrument it on one place. You can build it in the same place that you can piggyback your existing functional testing, however you do that, and you can get the dual benefits of adding a security check at the same time while matching the speed that the team is looking for. Of course, the problem with this is that we're only really catching things at the sandbox environment, so it could be something that came up through dev and QA that's a security concern that made it through the other testing, and now we're kicking it back, which might take that earlier change that we thought of in the morning and wanted to deploy it to in the afternoon, and now we're saying, nope, there's a security problem, you got to go back, and delaying that a little further. So we thought, what is the best way to do this? So the idea was we'll still keep the gatekeeper process, but in phase 2, we pushed this test to the left. And so we started installing contrast on QA and dev servers, right, where things were getting deployed from different branches of the code repo. And the idea was that as things were being tested by the developers manually and through automated means, contrast would be feeding stuff in, and before it could be promoted to the next stage, we could kick back any security findings that needed attention. Phase 3 that we're in the process of finishing the automation for is this idea of we're going to do individual dev testing, so that the individual build environments that developers are testing their own changes before they merge those or do a pull request into any of the development branches, is that we're actually able to run it directly there locally and give them feedback instantly from their own local dev environment, so that they don't even commit code with vulnerabilities that we're detecting really early on in this phase. Okay. Item number 4, keep the devs happy. That's an important step. Wouldn't you think, Brandon?
Yes, I totally agree. I'm 100% behind that statement.
So when we set this up, Julie and I were trying to work with the development teams, and we wanted to make sure that this was something that we didn't cause extra work for the developers in terms of having to go one other place to find the tickets that they needed to work on. We wanted to make sure that they had everything that they needed here. So we worked with Brandon and his team to figure out how do we put this into the same workflow that they would use today for any other bug ticket that comes out. So that's exactly what we did. We used Jira, and we were able to flow the same data directly from contrast that meets some predefined criteria we come up with in the contrast application, flows them in there, and we can assign them to the right development resources, and it's got all the information they need in the ticket. They still have access to the contrast application, which some of them use, some of them don't. They don't necessarily need to. It's all a part of what the developers prefer. But the idea is they have the full context and details of what the issue was and what the recommended resolution is, and we're able to really give them actual priority and significance of issues, right? Not every security finding can be critical. Sometimes they're minor things that we can address later. Sometimes they are problems that we actually have to take. But I think the biggest one was giving the development team the opportunity to help build the process here, because I don't know if you know this or not, but unhappy devs will always find a way around your security process, kind of like raccoons opening a trash can. I am not saying that developers are raccoons. I'm simply saying like that, they will find a way around your safeguards. Okay, keep the auditors happy. Julie, I'm going to let you take this one since you are the resident auditor.
Oh, thanks, Ben. I'm not technically an auditor, but I do think like one sometimes. Mm-hmm. Okay, so keeping the auditors happy. This was really important. We've actually already been through one round of SOC auditing with our auditors. So a couple tips for those of you thinking about moving into this automated pipeline. One, make sure the entire process is documented. I can't say this enough. While we thought we did document everything, the one thing that we neglected to put back into the documentation was the legacy processes that were still happening. So, for example, we had a kind of you find it, you fix it, bug fix team working. While they weren't doing anything wrong, when we updated all of the documentation for the microservices, we neglected to put this you find it, you fix it team back into that documentation. And so when the auditors pulled those tickets, they didn't look like the microservice tickets. We ended up having some issues during the audit for that. So as you're working through your documentation, don't only consider what you're currently doing, but make sure anything that remains in your legacy process does get updated as well, even if it's following the new microservices process. Just keep an eye out for that. That was one we didn't think about. The approval of code for prod, so this is another important one. Ensure that your tickets are showing all steps in the process. So if you're doing automated testing or it's going through QA or you have a security tool, make sure that they're all being documented into the ticket. For us, we're using Jira. Luckily, all of our tools integrate with Jira, so we're able to get that automatically updated. And the auditors didn't have any problems with the automated testing as long as we could prove the testing was working and what we were testing. Jira ticket created for every build. Again, this was really important. Make sure that you're not leaving legacy out of this. So if this is your new process, make sure that you include your legacy environments. Ben, do you want to talk about the use version commit numbers in your testing? This is one I think you can with.
Definitely. So one of the things that we were able to do to tie what Contrast was reporting back to make sure we understood specifically the version and the stuff was when we would deploy it, we would use some environment variables, and actually the version information that Contrast would report back to us, we would tie directly to a commit identifier in our software repository. So when we went to show that something was either approved or had a finding, we could tie it directly to a commit and see that code. And that was really important for us to make sure that those things were easy to sync up, so you didn't have to go look at some table someplace to compare, version 1.11 is this commit number in the repo. And that made it really easy for the auditors too to match up what we did. As you can see from the previous one, the automated process actually creates a ticket for every single build, and we were able to add a very simple webhook in the continuous integration server to query the API and to record the output of the testing. And what was cool about this was not only did this make it easy for us to tie it back together, but it made it really easy for the auditors to see that the testing ran here.
Thanks, Ben. The only other thing I would advise people of is keep in mind that if it's the first time you're going to go through a SOC or SOX audit or some other regulatory audit, make sure you build in a little bit of extra time to the audit, because your auditors, if they have not seen an automated pipeline, will usually take extra time. They need time to understand what's happening in the pipeline, and usually you're going to have them interview staff that maybe they've never talked to before. So for our case, what we had to do was we got product team involved because we needed to prove that the developers had been authorized to start working on whatever projects they were working on. And we had to go all the way back to the start of the quarter with the large projects. So while code might have been deployed 30 to 40 times a day, we did still have to show that at some point in time a larger project was envisioned and that the C-level and then the product team had also approved that it was going to happen. The other thing is that we do deploy, I don't know, do you call it dark, Brandon? I call it dark or off. And so we do continue with release notes to customers. So while we are deploying daily, customers may not see the change until a larger release, depending on the product. So for the audit, we were also still able to provide release notes that would go to customers, and that was part of our audit process as well as contract. All right, Ben, I'll let you take it home on the next slide.
Awesome. And so the last step was, of course, to keep the security team happy. So some things that we learned from this when we put this thing together. Number one is automate whenever possible, especially in the case of here where the rest of your environment is automated. You will go nuts trying to keep pace with an automated system that is deploying continuously throughout the day. So you absolutely have to come up with a way that you're going to get the logical flow of what it is you want to look for down and defined so that machines can do it for you. Of course, one of the great joys of I think this security team is that we pride ourselves on not being the team that says no. We try to find ways to make things happen and to open up the possibilities for our developers to build within. And I know this is one that some places are still working on it, right? Because things are marching out maybe faster than you can control. But that's really our goal, was to try to come up with ways to create new opportunities for the dev teams and not just tell them no. And then, of course, the other thing is sharing our experiences with our peers in information security, like at talks like this exact thing, right? It's fun to know how other people have solved this problem and to kind of, commiserate on some of the pain points, and then also to celebrate some of the wins like this. So if we go back and we look, we've been able to go back and check the boxes for all 6 of these items, which is cool. Julie, I think, as the self-assigned goal, I think we definitely checked that one, but it seems like we're getting validation that we've done the other 5 as well.
Yes, I would agree.
And so Brandon was nice enough to let us help. It was helped us think about how do we put security into his pipeline. And so Brandon was able to put this together for us. And Brandon, I'll let you walk the team through just a small couple changes we had to make to get security in here.
So yeah, I mean, it kind of belies the massive amount of work that the security team did, but they were able to actually very nicely settle right into our pipeline, and basically it's a build process now, right? Any one of the containers has security as part of its pipeline deploy. If it fails the security standards that we put in place with contrast, it breaks the build, and that does not go past that gatekeeper. So it's really been very impactful with how we're able to continue with the speed of our deployments that we set out to do after reading the Phoenix project, and has actually given us the confidence to deploy those things as quickly as we are, along with all the various testing. In the end, now we just view it as basically another part of the QA process, which I think is the appropriate way to be thinking of security. It's QA, it's functional, it's load, it's security. That's all part of QA, and getting those things bulletproof and repeatable at scale is hugely important, and this has allowed us to do that with our security aspect of our quality assurance.
Awesome. So some people ask us, what kind of skills would we recommend, people in InfoSec who want to, go after some of the same projects like this. And thanks a lot to Brandon and a lot of his team who helped us really point us in the right direction to learn this. So I think some things we've learned for sure is you need to be able to read and probably write a little code, right? I mean, this is important. This is the new language you got to speak, right? Because this is the product you're actually putting out. You got to have to know how to defend. You've got to be able to do a little bit of that, if for no other reason than to do your own automation. You really need to understand sort of the containers and the different methods for managing some of these DevOps type platforms out there now. You should definitely know how to do, at least at the basic level, the containers that you could run on your own premises, as well as different platform as a service offerings. You don't necessarily have to know all of them. Just know a couple of them, and you know the foundations, and you'll be able to be pretty fluent back and forth. Continuous integration, I think, is something that's kind of a black box for a lot of security people, especially if you come from the infrastructure side. Continuous integration can be your friend because there's a lot of stuff that checks you can build in right there that, as Brandon mentioned before, that you could fail a build and prevent something from going into production that doesn't meet a security definition. If you can know how to articulate that and put that into something that can be built into the CI process, then you've just built a check for yourself. Infrastructure as code is your friend. We talked about it earlier. That will let you know literally everything that is installed and how it's installed and configured on the underlying platforms that the apps will be using. And it seems like, and it's worked out for us, that InfoSec teams are kind of the natural bridge between like development and like old school infrastructure teams, right? Where you kind of have a foot in both worlds, and you can help make those things go back and forth. And so you can sort of see yourself as having the ability to impact the whole thing to make everybody work better together and make the product more secure.
Okay, in terms of call to action, hopefully we've whet your appetite during this presentation, and in terms of next steps for the audience of the webinar, we encourage you to try out the Contrast Community Edition. It's a free version of our software. At Contrast, we had an official announcement about this a week or so ago, and basically it not only empowers, but puts development teams in control of the software, it also allows security teams to improve and even augment their current security tools and posture. Doesn't require any heavy security expertise. Basically, you just need to identify and find an application that you can use. It's very easy to set up and get going. And it fits and integrates within existing processes and tools that you might already have. Basically, our Community Edition is based on our Contrast platform. So basically, you might be familiar with Contrast Assess, which is a tool that's used in development, QA, and testing environments, as well as Contrast Protect for production environments. So we encourage you to take us for a test drive and start self-protecting your software. And by using this Community Edition, you'll be able to see how you can remediate vulnerabilities early on in the software development lifecycle and monitor and defend against attacks in production environments. Next slide, I think, is Q&A time. All right, so we've already got quite a few questions from the audience. As I look at the question, first question is, how do you prevent developers from deploying Docker images not in the trusted registry or from overriding testing results from Contrast?
Javed, this is Ben. I'll take that one. So for us, we solved this in a couple of ways. The first one was we just restricted the permissions in that environment. We used the idea of like the automation, right, doing all the work, is saying that humans can't be in here because you'll get in the way, right? The robots are going to do this at a much more precise and much quicker pace, and so we need to restrict the rights of different people to go in there. Of course, we have the usual break-in case of emergency type accounts, right, where people can get in there if human intervention is needed. That has not happened to us yet, and so that allows us to make sure that nobody has the ability to push their own container images in, like outside of the build process. And the build process itself, we configured to look for only deploying the images out of the trusted registry. Right, so that's actually some pretty strong controls. But we also monitor the logging of our different Kubernetes clusters to see when things are stood up, and so we can get alerted if we have something unusual that gets stood up that doesn't match a name that we kind of know and trust.
Okay, great. Next question. How do you build a relationship between the development and security teams to make this kind of integration possible?
I'll take this one. So I think the first thing I would recommend is, one, sit down with the developers and find out why they're building the pipeline. Get it from them. What inspired them to make this change, and what's most important to them. So in our case, the application architect who read the Phoenix project had decided that he was going to try and get rid of our Brad. And Brad's a character in the story who's sort of a bottleneck for everything. So once I understood that, and then I really understood what was important to them, which was speed. Speed in this was the most important thing to the team. They wanted to be able to deploy quickly and consistently. So that really helped me when I was looking for vendors. The other thing that I think really helped was that I did give them the ability to say no to different security vendors. So even though if I found one that I really liked and they checked all of my security boxes, if the developers just didn't like the way that the conversation was going, they didn't feel like the security vendor understood the automated pipeline, they did get the final say to say no. And this really built a lot of trust. I think it probably indicated to them that I was really listening to them, and I was willing to meet them really where they were at and what they were building. Brandon, do you want to, maybe you can chime in on how you think we built that trust?
Yeah, I think the last thing that's important to note is, just the discussions are great. Going back to Ben's last slide, or one of his last slides about, learn a little bit of code, learn the environment, do that stuff, that garners an awful lot of trust from the development team that the security team be working with, that they are, making an attempt or even understanding, really understanding what it is that they're trying to do versus just trying to put blocks in place. So it really became a team effort at that point. It's difficult for a developer to stand up and say security is not important, right? But understanding that's one thing and implementing it is another thing. And being able to meet halfway like that gets through some of the egos that might otherwise stand in the way. And I think that was part of our success in this project.
Okay, great. Next question we have is, how do you verify that a container is running with only approved software?
Yeah, so I can take that one. That's kind of a multi-faceted thing. The main thing that prevents it is that gatekeeper process that Ben was referring to earlier. Even prior to that, though, we've got checks in place. We've got a set of pre-approved images that you can start a service from. We also have our Git repositories locked down. Each image that is deployed starts with a Git repository, and there's only a handful of people in the company that are even allowed to create a Git repository. So prior to creating a new service or a new container, it has to go through a review by architecture, security, and our DevOps team. To make sure that it can happen. It's not an onerous process, but at least it's a checkbox to say, here's what I'm trying to do, here's the thing that I'd like to write it in, and here's my base image that I'd like to start with. And that's usually enough to make sure that everything is going to be appropriate as it moves forward through our build pipeline. Beyond that, we do have some agent processes that evaluate running software and against our standards. That's mainly against our development standards to make sure that it works within the process that we've defined, our overall platform requirements, different endpoints that are required, like a health check and application performance metrics and those types of things. That process runs nightly and basically sends out notifications when it finds that things are missing. So that process is slowly evolving as well. So it's a combination of those things, but we try to stop it at the beginning. Nothing can get into production unless it's gone through those two minimum gateways. The first one being the evaluation from the entire team that it's appropriate, and then the second one is that automatic gateway process between the Wild West of Mad Max and the rainbows and unicorns of something different than Mad Max.
That's great. Next question we have here says, what information do you provide auditors to satisfy requirements that used to be completed with SAST and DAST tools? Julie, this is probably down your alley.
Sure, I'll start this and then I'll have Ben chime in too. So the first thing is making sure, like we went over on that slide about the tickets, make sure that the test is actually listed in the ticket every time. The other thing that we did was then we would walk the auditors through the entire process, show them, in this case, because we're using contrast, we would show them the contrast dashboard, show them everything that's coming back. And I think that really helped them, but really walking them through what was in the ticket was probably the biggest thing that we had to do. The other thing is giving them time with the head of QA, who spent a lot of time talking about her process in the automated pipeline and just how QA was automated as well, gave the auditors a better feeling about what we were doing. Ben, do you want to follow up? Because I think you do a few extra steps as well.
Yeah, so I mean, the ticket is definitely key, right? Because that really tells the story of every single build, whether it fails or succeeds. It's all charted there exactly as to why it failed and why it got kicked back, and then you can see the subsequent builds that fix that issue and see how they get retested to make sure that they're clean. I think it's really important, and you kind of touched on it, Julie, that zero findings is not the same thing as proof that the test ran. So one of the things we did was that webhook from our continuous integration server to add a note in there to show that the testing occurred on the piece of software. I just didn't find anything that met our threshold for preventing that build from moving forward. And I think that was That was a pretty critical part of it. And I can't stress enough, when you match up the commit and version numbers that mean something to you inside the contrasting, it makes everything flow a lot easier. And that made it very clear when we showed them between the contrast application itself and our ticketing system and other things, that they could very clearly use those identifiers to move between all of those pretty seamlessly.
Okay, great. Next question, we have still got quite a few questions. How do you scale this solution to work with larger teams?
Yeah, it's a really good question. I mean, the solution itself, just microservices themselves and the way that we're attacking them, there are some potential areas where you can get conflicts, particularly if you get a lot of people working in a similar area. The way that we try to combat that is through practice and through convention more than anything. We don't apply any sort of technology to that. The hope being that first of all, we try to keep the services as small as possible. So limit them to a single concern. So the smaller the service, the fewer people that will have to be there, is the theory behind that. And the second thing behind that is that we try to keep the changes that we're making as small as possible as well. I mean, we're looking to deploy 20 to 40 times a day, or we are deploying 20 to 40 times a day. Obviously, we're not spending 6 to 8 weeks on each change, and then they all happen to come through 20 to 40 times a day. I mean, we're averaging a consistent 10 to 30 deployments a day. So we're keeping those changes very small, like thinking about like an hour of code changes, and then moving it through the process in, over the course of a couple of hours versus, a week, 2 week of development, another week of QA, and then, process it through from that perspective. And that's given us a lot of benefit with velocity, but also with deployment durability and testing durability. And obviously, the more often you do those deployments, the more often it's being exercised through those different pipeline steps at later points in the pipeline, those being security, load testing, and static analysis. So the more often we're exercising that, the more durable those get. So that's really how we kind of try to attack it with our larger team that's working on these services.
And I'll just add one thing. As the developers have grown the microservices environment, the security team has had to decide, or we made the decision to also add another team member who can support specifically this microservices environment. So we're actively going to start looking to hire probably either somebody who's a current developer and interested in security, or somebody who's come into security from the development world. As we look to expand our ability to support and directly work with the developers, as Brandon said, this was really important that we maintain this trust relationship.
Okay, great. We have a two-part question. Says false positive rates in contrast, how usable is it? And then the second part of this is, can you connect with other tools like ticketing and bug tracking? And I don't mind, taking a stab at that and then getting the Beeline response in terms of how you used it. In terms of false positive rates, right? We know that false positives represent probably one of the biggest single issues in AppSec testing tools today, right? It increases a lot of the workload, especially when you've got scarce resources in security, et cetera, and it makes it difficult to identify the most critical flaws from those that are maybe benign. In contrast, we know that we can significantly reduce the amount of false positives. And then the second question in terms of integration, we can integrate with the tools that you're currently using within the developer and security environment throughout your SDLC. So in the testing environment, we can integrate with CI/CD frameworks like Jenkins and Maven and Bamboo. In development environments, we can integrate with ChatOps and IDE tools like Slack and HipChat and Eclipse. For QA, we can definitely integrate with bug tracking tools like Jira and Bugzilla, where you can automatically generate tickets and push out notifications. And finally, in an operational environment, we can integrate with SIM tools like from Splunk and other tools for forensics and notifications. So for the Beeline folks, false positive rates and connecting with other tools.
Yeah, this is Ben. I'll take that question. So false positives rate, it's definitely a lot better than what you would have seen out of like the standard dynamic scanner where you run it and then you have an 1,000-page PDF of all kinds of stuff that turns out to not be true, right? That is absolutely not been our finding. I would say, I don't know that I've seen anything that I would definitely describe as a false positive. There's been a few findings that are true that I would say what they're talking about is correct, but that is we take care of it maybe in a different way. So it's not remediated in the sense that the vulnerability doesn't exist, but it's extremely difficult to exploit. That doesn't mean that it's a false positive per se. It's just things that previously we would have listed as like a sort of a false positive, but those are still things that get put on our list for the software team to fix when that when based on the priority and sensitivity. I will say we did find when we put this in place on one of our apps and a really obscure like edge case module that very few of our customers have involved on an admin panel, we did find this one field that turns out to be SQL injectable that we were able to find and fix, and that really bought a lot of goodwill from the developer team because they looked at that and like, that was really good. I would say that the interface is a lot nicer than a lot of the AppSec tools. Our developers are used to working with some of the big names that I'm sure you're familiar with, and they were all commented that they like the way the contrast one is built, the ones who use it. We do have it connected in to our ticketing system, and that's one of the ways we flow findings to our developers. And we also use some of the webhook capabilities and the continuous integration servers, and all that has worked great. And we use the SaaS hosted version of Contrast, and that's been really easy to work with.
Okay, great. We got a couple more questions. The next one is short and sweet. How easy was it to deploy the solution?
I'll take the first crack at it. So for us, this has been, we were able to get, so we used the SaaS version, so we didn't have to stand up our own team server, as they call it. So that part was obviously super simple. Getting the agent installed actually is really, really simple. And if you show it to the developers, they can almost immediately, it took us, I think, the first day we had it installed in like a test mode, and then we were just tuning and figuring out the best options to turn it, to enable so that when it showed up in the agent, it had the right names and it was easy to identify, like, the version and those sorts of things. But I would say in terms of getting that thing from out of the box to being functional, you could definitely do a 1-week POC and be getting a lot of value out of the tool.
Okay, great. Last question that I have so far. Where do I start with Contrast? What's the first thing I should do? From a Contrast standpoint, as we mentioned in the call to action, we have a free version of our software called Contrast Community Edition. So basically, you just need to identify an app. It's easy to set up and get going. Beeline, any feedback from your standpoint?
This is Ben. I'll take this one too. I think really pick one of your dev type environments and just get the agent installed to get it instrumented and just start kind of playing with it. And show and tell with the dev teams is a good place to start. Everybody always likes cool new shiny things, and I think for us the cool thing was just to get in there and that right as soon as it runs, it gets a complete inventory of all the libraries that are used in the software, along with like the number of classes from that package that are in use was awesome to see. And so that's why I would just find a dev or a QA server, instrument that as kind of like how your sandbox, how you're going to figure out how to get this thing going for real, and then get yourself deployed until you're ramped up to where you need to be.
Okay, that's great. That's all we've got in terms of Q&A. I think we might have one or two more slides if you just want to move that forward. And some great questions there today. In terms of contact information, you can see some contact information and a URL for Beeline if you want to find out more. And I guess that concludes today's presentation. I'd like to thank our presenters at Beeline for a very informative presentation and great insights on how they've secured their automated pipeline. We hope you found it valuable and interesting, and a recording of this will be available shortly, usually within 24 hours. So feel free to use the same URL that you used for today's webinar once the recording comes out to review and to send to your colleagues. Again, thanks very much, everybody. Greatly appreciate it.
Thank you.